Hello, my name is Ishaan and I'm a student at Glencoe High School. Today, I'll be teaching you about recursive functions. The idea of a recursive function is a function that calls itself. Many people say, to first understand recursion, you must first understand recursion. Well, a recursive function, an example of it is f of x is equal to f of x minus 1. However, if you keep on calling a function inside a function, that's going to lead to infinite calling, which is called infinite recursion. That's why the second part of every recursive function is the base case, which is a case for x that is actually equal to a numerical value. So for example, f of x is equal to f of x minus 1, f of 0 is equal to 7. Now, let's look at the factorial function to better our understanding of recursive functions. So, for those of you who know, the factorial function is a number times 1 less than that number times 1 less than that number, and so on. So for example, 4 factorial would be 4 times 3 times 2 times 1, which is 24. The recursive function for that is f of x is equal to x times f of x minus 1. And the base case is f of 0 is equal to 1, because 0 factorial is 1. So, let's evaluate this. So, f of 4 is equal to 4 times f of 3. Now we slide down and we have to evaluate f of 3. F of 3 is equal to 3 times f of 2. We have to slide down once more and evaluate f of 2. F of 2 is equal to 2 times f of 1, and we have to slide down again and evaluate what f of 1 is, and that f of 1 is equal to 1 times f of 0. Now, f of 0 is actually equal to 1, so we can change that to 1, right? So f of 1 is equal to 1 times 1, which is 1, and that goes up to here, and that changes f of 1, which has now been evaluated to 1, right? F of 2 is equal to 2 times 1, which is equal to 2, and that subs back up to f of 2. So now, f of 2 has been evaluated to 2, and then f of 3 is equal to 3 times 2, which is 6. So f of 3 has been evaluated to 6, and then f of 4 is equal to 4 times 6, which is 24. And that's what we got. So, to summarize, but what about negative numbers, right? What if I did negative 5, right? The base case would never satisfy. That's why, to help the base case out, we have to say that x must be greater than or equal to 0. And that makes sense, because you can't factorial a negative number. So, to summarize, a recursive function has two steps. The recursive step and the base case. You have to make sure that the base case stops infinite recursion, and you have to make sure that the preconditions are valid so that there isn't any case where there can be infinite recursion. While many people say you must first understand recursion to understand recursion, I hope you finally reached the base case.